So did you find a definition for ionization? Right, so the first question is just asking you, why does removing an electron even require energy? Second number 11 bullets in it. What's new? The electron? Okay, well, but why does it require energy to make that electron move away from the nucleus? What do you think, Brendan? Why would it take energy to pull an electron away from the nucleus?
That's why. See how
That's exactly right. Okay, let's pretend, like, grab my finger, okay? Let's pretend that you're an electron and you're going to pull away from me and I'm the nucleus. So I have attraction for you. So I'm going to pull and you keep pulling. What do you have to do to pull away from me? Pull harder. Okay, you have to pull harder. So you're actually having to put energy into pulling the electron away. Yes.
Yeah, a couple questions. For like 9 through 11, like I notice how it jumps, like it or no, like decreases. Is that because like these are metals and these are not metals?
Right.
But then how are you like they both are increasing?
Are you talking about ionization energy?
Yeah.
Right.
Yeah, like decreasing. What would happen if we have more metals? Would it just keep going?
Well, when you take that leap from beryllium to boron, well, actually from beryllium to boron, there's nothing. So it's actually you have to go all the way down to calcium to actually get to where you would have metals in the middle, and those would be your transition metals. And those are the metals that don't follow all the rules, so that's why we left them out.
I know, but like, how are we supposed to explain the trend if there really isn't one drop?
Oh, because you have a couple of little wiggles.
Yeah.
Just go with the overall trend that you see there. It's kind of like, you know how in the stock market, like we say the stock market's going up, but there's still like little dips that happen.
Mm-hmm.
So it's the same thing. If the overall trend is that it's increasing, that's what I want you to observe. Yes, go ahead. Timer. Timer. Oh, yeah.
Find it. I don't know where it is.
So let me stop you guys just for a second. What's your compound? Lithium chloride. Okay. So which one of the elements in your set of elements has the highest electronegativity?
You look at this one.
Okay. Do you guys agree? So, Lane, what do you think that means? Like when you're trying to talk about a chemical reaction happening, what is the fact that chlorine is more electronegative or has a higher electronegativity? What does that mean is going to happen? So what I'm wanting to know is what does that mean? Since chlorine has a higher electronegativity, what's it going to do? Okay, so what does that mean that it's going to do to hydrogen? Or lithium? No, it's lithium, right? What's it going to do to lithium?
Well, it's already got a weak but it's got like a weak ionization.
Which one? Right, yeah, you're exactly right. So what does that mean?
wouldn't it be
No, I'm not asking you. No, it's okay. I'm not asking you what type of bond it is. I'm just trying to get you to tell me what's going to happen to the electrons. Since we know that chlorine has more electronegativity, and then you just said lithium has a low ionization energy. Here's what I want you to do, and everybody do this. Write the electron dot structure for lithium. You can just write it at the bottom of your page. That's the Bohr model. That's not the electron dot structure. Draw the electron dot structure, not the Bohr model. Okay, and then draw the electron dot structure for chlorine, right next to it. How many valence electrons does chlorine have? 7. Okay, so, Lane, you just said that lithium has low ionization energy, which means what? What does that mean, Michaela, if it has low ionization energy? You know? Okay, what does it mean? Okay, so what does that mean about its valence electron test? Right. There's not a strong hold on that electron, right? So that means that it can lose it easily, correct? Okay. So, and then, Michaela, try this one. Since chlorine has a high electronegativity, what do you think chlorine is going to do to lithium's electron? Right, it's going to pull it in, right? So how could you draw that? Show that in your little model there with the electron dot structures. There you go. You've made a little arrow. It shows that electron's going over there. Now something very important happens here. Because when lithium loses its electron, what happens to it? What happens? Yes, but what happens to the atom, the lithium atom? Not negative, positive. Okay, so put a little positive sign by your lithium because it becomes a positive. And then you will put it up here like it's a charge. It gets a positive charge. Put it up there like it gets a positive charge, like an ion. And then what happens to the chlorine? Because it gains the electron. Right. And then what do we know about positive and negative charges? They attract each other. Okay? All right. So